and welcome to episode 8 of Cloud Tech 10 for the 1st of May 2017. I'm Mark and I'm going to tell you all the latest news about Microsoft Azure from the past week in 10 minutes or less. Visual Studio now features support for setting up continuous delivery DevOps pipelines with Visual Studio Team Services for deploying a .NET or a .NET Core web application to Azure. This uses the continuous delivery tools for Visual Studio extension. With your application open, click on the Build menu and select Configure Continuous Delivery. If the application has not been configured for source control, instructions are displayed to help you get that set up. I click the Add this project to source control link and Team Explorer is displayed. I click the Publish Git Repo button and Visual Studio connects to Visual Studio Team Services and suggests a repository name. I click the Publish Repository button and my source code is pushed to a new repository on Visual Studio Team Services. Next, I go back to the Build menu and choose Configure Continuous Delivery again. This time, as the code is now in a source control repository, I see the options for configuring continuous delivery. The default options will use the master branch and deploy the code into a new Azure App Service and web application. After a few moments, continuous delivery has been set up, and if I go to the Azure portal, I can see the new app service and click the link to the new web application. And here's my new website. So what just happened? Well, if I go to Visual Studio Team Services, I'll see my application has a repository. Here's my source code. But if I now click on the Build option, I will see that my application was built inside of Visual Studio Team Services and then pushed to Azure using build and release tasks that have been automatically configured for me. If I return to my application in Visual Studio and make a small change here, we can then go to the Team Explorer, commit my change, and push it back to my Visual Studio Team Services repository. That's all I need to do. Upon receiving the changes, Visual Studio Team Services will initiate a new build. I can see that here and that it's currently in progress. Once it's complete, I can switch to the releases view and I'll see that build is now being pushed to Azure. Once that push is finished, I can return to my web browser, refresh the page, and there's the change that I made to my website. All I had to do was commit my code to the repository and Visual Studio Team Services handled the rest. The Cloud Application Development team has published a series of labs that help demonstrate how it's possible to integrate the advanced capabilities of Azure API Management, Azure Functions, Logic Apps, and Cognitive Services with existing on-premises workloads. The labs have been open sourced and are available on GitHub. They are easy to set up and provide a great pre-built environment in which to familiarize yourself with several Azure services. Here's a quick walkthrough of how to set up the loyalty scenario. This lab simulates a legacy system that holds customer feedback data and shows you how this system can be hooked up with Azure services. In the GitHub repo, you'll find this nice big Deploy to Azure button, which handles the vast majority of the lab setup. Simply click it, then once you're in the Azure portal, provide a resource group name and a new name which will be used to name the resources used for this deployment. It takes about 20 minutes or so for the deployment to complete. When it's done, you'll find a resource group with an app service containing an API application, instances of API management and Azure functions, a virtual machine running Ubuntu Linux to provide the legacy on-premises application, and some storage and networking resources that these services make use of. I can check the API application to make sure it's working as expected. Just click on the URL here and add docs to the end of the URL and you'll see the Swagger metadata. From the API application's Kudu console, I can modify the contacts.json file to provide a real email address that can be later used to test the functionality of the solution. In API management, I can import the API from the Swagger metadata, go to the publisher portal and choose Import API. I select the option to import from a URL and add the URL of the API application with Swagger at the end of the URL. I give the API a name and that will form the URL used to access this API and choose the products I want to associate this API with. Hit save and it's done. Now I can go to the developer portal to test the new API. I click on APIs, then Contact List API, and then try it. In here I can see the API access key that I'll need to use later when I'm building the solution in the lab. If I click send, we can see a response which includes the list of contacts I edited in Kudu earlier. If I can see this, then the API is working as expected. Now let's set up the virtual machine that will host the legacy application. It's running Ubuntu Linux, so let's SSH into it. Now I clone the Git repository that contains the source for the legacy application, and then run the install VM script to deploy the application. This takes a few minutes to complete, but it's fully automated. When I see the starting legacy API message, I know the application is ready. The next step is to import the legacy application's API definition into API management. I follow the same process as I did earlier, this time specifying the private IP address of the legacy application's Ubuntu server that we just configured. As before, I can go to the developer portal to check this is working as expected. Choose APIs, then Contact Case API, and try it. Next, hit send, and I'll see this message back from the API telling me that it's working fine. The final part of setup is to configure Azure Functions. Back in the GitHub repository, there's another Deploy to Azure button that I'll click. I give it the same resource group and deployment name parameters parameters that we used when we initially deployed the lab solution, and away it goes. After a few minutes, the deployment is complete. Let's go to the Azure Functions, and under Platform Features, I'll find the Deployment Options link. Click this and hit Sync, and the Azure Functions code will now be pulled and built from the GitHub repository. Once that's complete, the function can be tested by choosing Generate Coupon. Then on the Test tab, we add a key value pair like this. Click Run, and a coupon URL is generated. Now that all of the components are in place, it's time to hook everything up using Azure Logic Apps. That's the fun part for you to try, so I won't show that here. But as you can see, the labs are quite simple to set up, and this is a great way to learn how to integrate various services in Azure. A new role has been added to allow read-only access to billing information. Users assigned this role are able to view billing information for an Azure subscription, but without access to Azure resources such as virtual machines, web applications, or storage. In the Azure portal, go to the subscriptions view and select the appropriate subscription. Then choose the Access Control option and click Roles. Scroll down and select the Billing Reader role. From here you can view the permissions assigned to this role, so you can verify the exact level of access that the Billing Reader role has. Clicking on Add will allow you to select the users or groups that you want to assign to this role. With that done, the user with the Billing Reader role can now log into the Azure portal. Click Subscriptions and they'll see that their assigned role is now that of Reader. From there they can navigate through the billing and invoicing information in the portal. 3 new services are now available in the UK Azure regions. The fully managed cloud Hadoop offering, HD Insight, is now in the UK. The Azure Import-Export service, which supports movement of large volumes of data by physically shipping hard drives, is now available in the UK South region. And the Azure Container Registry, which provides a private registry for hosting Docker container images, is also available in the UK. The Azure IoT Gateway SDK lets you build IoT solutions tailored to your exact scenario. For example, it can be used to enable existing IoT devices to continue to use their existing protocols, ingest the protocol data, modify and process the data as needed before sending it on to the Azure cloud. The SDK has been available since November 2016, but it has recently been updated with the addition of packages for popular languages. These include NPM packages for Node.js, which also includes a scaffolding module for use with Yeoman, Maven packages for Java, and NuGet packages for .NET. Using these packages makes it much quicker and easier to get started writing modules for the Azure IoT Gateway SDK. All of these packages are open source and available on GitHub. New Azure management libraries for both .NET and Java are now available. These new libraries allow you to easily manage Azure resources from .NET and Java applications, performing operations such as creating new virtual machines and virtual machine scale sets, managing storage accounts, SQL databases, Key Vault, Redis Cache, or Azure Batch, and various network-related tasks such as managing virtual networks, IP addresses, network security groups, and Traffic Manager. Both sets of libraries are open source and available on GitHub. Along with the source code and full details of supported features, you'll also find comprehensive usage details with code snippets showing you how the libraries are used and a large selection of sample code covering pretty much everything you might want to do. Version 2 of Azure Media Player is now available. The new version adds support for advertisements, including pre-roll, mid-roll, and post-roll advertisements that can be configured to be skippable or non-skippable. Version 2 of Azure Media Player also adds a new skin called AMP Flush. It's easily enabled by making a couple of simple changes to your CSS and HTML files. That's all for Cloud Tech 10 this week. Don't forget, tell your friends, like, share and subscribe, or follow me on Twitter. I'll see you next week. Cheers for watching. Thanks for watching. If you enjoyed this video, don't forget to like, share, subscribe and follow me on Twitter for more.